Okay, I think I'm streaming. If I'm streaming, that would be great. That would be really good. All right. All right, so we're about to get started, everybody. This is gonna be good. All right. Hello, world. Welcome to the first live stream for this course. I'm so excited to have you guys here. I am going to, first of all, answer some questions, and then we're going to do some coding, all right? So I'm gonna do a code walkthrough, and then we're gonna keep going. So first of all, first 5 minutes, let's answer some questions. The great thing about doing this on YouTube is that if you're watching this afterwards, the recorded version, you can see you can see everybody's chat. So let's answer some questions. What kind of questions do we have here, guys? Let's see. Let's see. Increase my mic volume? I can do that. Let me increase that all the way up to here. How about that? There we go. Okay, so first question is from Kapil. He says, we're using Flask, however, isn't Django better for production? Not necessarily. Look, guys, it's really, when it comes down to it, the differences between these tools is trivial. It is minimal. It's just about making something, putting it on a cloud server, and then serving it to people. It's not going to be perfect. It's never going to be perfect. Even if you're a 10-year-old company, it's never going to be perfect. I mean, look at Reddit, for example. Sometimes you visit Reddit and the app crashes, right? And Reddit's like 10 years old. So it's really just about putting something out there and then iterating along the way. You know, after 2 years or even after 1 year, you can find a new web app framework and use that instead, right? So it's all about this iterative, rapid experimentation process, which is one of our values at School of AI. Shiva Krishna has a question. Is there a common group like Slack where all the peers can discuss? Yes, there is. I sent it via email, and if you didn't get the email, check your spam folder. For the assignment part, whether the model is trained using webcam can be saved, how to do that. Yes, so it can be saved. It's saved as what's called a pickle file, which you can then load up again. And I'll actually show you how to do that in this tutorial. Jack says, what are the goals of the course and what is the next step if we graduate? Jack, great question. So the goal of this course is to get you in a state where you are confident and capable enough to start earning money using machine learning. And there are 3 paths that I've outlined for this. The first is to do consulting work. That means doing some kind of one-off programmatic activity for somebody that's going to earn you wealth, whether that's classifying images or predicting the target label for some economic data set, or any number of one of a million different possibilities. The other is to get a job, and that's really all about building a GitHub portfolio. Like in 2019, GitHub is the new resume. So if I'm an employer, and I actually am an employer, I do have employees. What I do is, if I'm looking for a coder, I look at their GitHub profile, right? That's the new resume for coders. You can say anything on your normal resume. You could fake it till you make it, whatever. But your GitHub is different because you can see the commit history. And this is in the form. Let me show you guys what I'm talking about here. Just a little. Whoop, there I go. I'm small. Let me show you guys what I mean here. When you go to somebody's GitHub profile, you can see their commit history. Take a look at this. All of their contributions in the last year. And you can click on one of their contributions, and you can see what exactly they did. Oh, he created a new library right here. He made a commit to one repository. Let's see what that commit was, right? And then you could go through the commit history, and you could see what exactly all those commits were in order. So you could see how they think. It's not just about what they've done, it's about how they think. Now that might seem scary, but that's the reality of the situation. All right? So that's something I wanted to really make clear. And lastly, it is not just get a job, but start a startup. And I think that's the one I'm most excited about. I don't know if you guys have seen, but there are so many capable, intelligent people in this Slack channel. These are people who are willing to change the world. They have the sustained motivation and enthusiasm to start a company with their peers in this community. We have already filtered for a common set of values, so that's a good thing. We have already filtered for a sustained enthusiasm for making the world a better place and earning wealth using machine learning, so that's a good thing. And now it's just about having that idea, finding someone who wants to do that, and then connecting with them. So that's all gonna happen, okay? I'm gonna coordinate that stuff. You know, we're in week 1 right now, so it's all coming. All right, so that's exciting. Let me keep answering some questions here. Risky asks how to put our code on GitHub. I still don't understand it. That's a great question, Risky. So, you know, my friend and colleague here, let me show you my friend and colleague. Let me make myself a little smaller here. My friend and colleague Daniel Schiffman has such a great playlist on how to use GitHub. And it starts right here at 1.1, Introduction to GitHub for Poets. There's Dan over here being amazing. And he really goes through these things in a really interesting way. And notice how it's a playlist right here. This is a great playlist, okay? There's also, this is like how I Google things. Yeah, this guy's, this simple guide, no deep shit. I love that. Look at this. Create a new repository, get in it. Check out a repository. I love this. Big, huge text. Beautiful, beautiful. So check that out, all right? Let me answer 2 more questions, and then we're gonna start with the code walkthrough. All right? All right, what are the other questions here? Yeah, I'm all about that startup topic. Tyler, just email me at hello@SirRogerVall saying, hey, I didn't get the Slack link, and I'll send it to you within 24 hours. Dan is a rock star. What's so special about a blockchain certificate, Sumit? Really, it's just a way to provide an authentic document in a decentralized way. So it's basically permanent. It exists beyond me. So if anything happens to me or School of AI or anything, it's permanent on the web forever. It's like engraving the certificate in a digital stone, for example. If we miss a deadline, do we get to submit it next week? Will it affect the certification? That's a great question. So if you miss the deadline, I will get mad at you. I will personally get mad at you because that is not, we are on a strict deadline here. So I will get mad at you, first of all. Don't miss the deadline. If you do miss the deadline though, I will forgive it. You can still submit it, and no, it won't affect the certificate. But if you do it something like totally crazy, if you submit like 5 weeks after the deadline instead of say 2, then it might affect your certificate, yes. So be very afraid of submitting after the deadline. Guys, we are on a tight schedule here, all right? I want to see you guys graduate this course. This is not a game. This is called Make Money with Machine Learning. We're not playing around here. There's never been a course named this. I've done this enough times where I know what exactly to do to bring you guys the most value. And one of those things is to stay on you and say, you better submit your documents, all right? That's what I'm here for, to keep you motivated as we do this. There's a lot of stuff we have to do. Let me answer one more question, and then we're going to start with this code walkthrough. Gopal asked twice, there are a lot of students in your course. How are you going to refer them all? And what will be your criteria for setting one of your students to a co-founder? Great question. So Gopal, first of all, I have handled much bigger populations than 575. School of AI is 800 deans. What I do is I use a series of tools to coordinate people that I've learned to use over time that makes things easier. For example, Google Forms. Google Forms are great to get a quick poll, a quick poll from people, and then categorize them into a CSV file. So what I'm going to do is I'm going to say, for every student who graduates, what is your startup idea? And select from a drop-down what your startup idea is going to be. Then that's one way to segment students. And then And then I'm going to look at what your GitHub profile looks like. I'm going to look at your qualifications. And I'm going to try to match people who are equally qualified together into startups. So that's for the startup bits. And then for the consulting bits, I'm going to say who wants to do consulting. For the hiring bits, who wants to do hiring. And then you can select which companies you'd like to be forwarded to. For the consulting bits, what type of work you'd like to do, and then it's going to be an email intro. All right, so that's it for the live Q&A. I went a little longer than I wanted to. I was super excited to talk to you guys. Now let's get into the coding bits. So here we go. Let me make myself small, and I will answer questions periodically. So I'll look at the chat every, say, 7 minutes or so to answer questions. So I want to start off with this, okay? This is TensorFlow.js, all right? Now, you might be thinking, well, you know, why are we doing both TensorFlow and Flask? I mean, these are two different languages. My point here is to show you something that not a lot of teachers will talk about. It's that the language really doesn't matter. You know, after a while, it just you just kind of like blow through the language. You just kind of... when you're looking at some code, you can basically see what everything is doing because it's all the same logic. What matters is logic. I'm trying to build a representation of the necessary logic in your head, and that's the most important thing here. So TensorFlow.js is a newer library, okay? So the original TensorFlow that everybody knows and loves is built in Python. Now, TensorFlow.js came out about a year ago, and it's a way to do the same thing as normal TensorFlow, but in the browser. Now, you could do the same thing with TensorFlow Python in the browser, but you would use Flask. But what I want to do is I want to show you both a JavaScript and a Python demo. Now, look at all of these amazing examples. Now, what I want you to do at some point this week is just go around and play with these examples. You know, what I mean by play is you can click on any of these, like let's click on Sentiment, and you could test it out live. These people have actually uploaded their web app to a website. Now, this is for sentiment analysis. I could load up a pre-trained model. Now, this is going to analyze a sentiment of some text that I have. So I say, hello. And in real time, it's analyzing the sentiment. I hate people. How about that? That's very negative. Negative thoughts. Bad, 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 bad. And it's saying, it's inferencing. So this is in real time. But if I say the opposite, I love people. Look at how that number changes. They are the greatest. I love everyone. Look at that 99.999 and positive. Okay? So this is the beautiful thing about this. Now just imagine what you could do with this in terms of making money. You could paywall this and say this is a tool for writers to see how good, how positive your text is. This is a tool for marketers to see how positive or negative your text is. So this is just one example of paywalling one of these open source repositories for your objective. Now, the one I wanted to talk about is, actually there's one more I wanted to show you guys. This webcam transfer learning. It's not going to work because my webcam is already in use, but this one's super cool. All right, so definitely check that one out. Now, I want to get to the one that I want to show you guys, and then the code as well. All right. All right, so also David asked a question, can we use TensorFlow.js with mobile like React Native? Yes, but we want to use Flutter for mobile, and we'll get to that later in the course. We're not even talking about mobile yet, but yes, your answer is yes. So here's the example I want to show you. It's called the iris classification example. Let's look at it live, okay? We're going to look at the code for this web app. So what it does is it structures some data about irises. So iris flowers. So iris flowers, this is a really common example in machine learning. And iris flowers look like this. There's 3 different types of flowers here. We've got versicolor, setosa, and virginica. So these are 3 different types of flowers, and they are all classified as such by a series of 3 features. Those features are the sepal width, the petal height, and there's one more, the sepal length. These are the 4 right here. Vikas, I'm going to answer that question as how to decide whether to use TensorFlow JS versus Python. So these are the features right here. Electric, I will save this live stream. And notice how we can change these features. We can change all of them. And we can load a pre-trained model, and it's going to classify these, just like that. Or we could train a model from scratch. Now look at what's happening as it's training from scratch. Our AI model, our machine learning model, is learning how to predict the class of all of these features. So the input data is the petal length, the petal width, the sepal length, and the sepal width. Then we have the true label, and that's what's in the data set, and that's it. Okay, so these 5 columns right here, that's the only thing in the data set. The 6th column, the predicted class, is what the machine learning model is predicting. And it's going to be mostly right. Okay, it's going to be mostly right. It's going to be predicting the probabilities of all 3 classes, the Setosa, the Virginica, and the Versicolor. And it's going to pick the highest probability. And that's a great question. Let me paste that exact link into the Slack channel. All right, let's go back to this. All right, so it's going to be predicting all of them in real time. And I can say how much I want to train. So notice with 40 epochs, it trains. So let me explain what's happening here. When an AI model is training, there are 2 things to consider. The first is the loss. The loss function is what decreases over time. It's a measure of how good your AI model is at predicting what the true class label is, the true target label. This applies to all supervised learning tasks, all machine learning tasks where a label is involved. A label is what you want to predict, whether it's iris setosa, whether it's cancer, not cancer, hot dog, not hot dog, the type of the geographic location of a place, the predicted stock price, I could go on and on and on. Whatever your predicted class is, the loss will measure how good your model is at predicting what that loss is, at what that label is. And it's going to be really bad at predicting at first, but as the loss decreases, the prediction is going to increase. And the same goes for the accuracy, but in the opposite direction. The accuracy is a measure of how far off the class probability that is output is from the actual class label. So this will increase over time, while the loss will decrease over time. And so that's what we're looking for as we train, and we can use tools like TensorFlow, TensorBoard to monitor that. And we'll talk about the TensorBoard later. We're not really ready to talk about TensorBoard. All right, so I wanted to show you a quick demo of how that works, and now I want to show you a little bit about the code. So what we can do for the code here is we can download the code. So what I'd first like to do is I'd like to show you an example of how to use GitHub to download one of these code repositories. Because remember, when you're making money with machine learning, you basically are taking one of these open source libraries from the internet, you are downloading it, you're adding a bunch of other features, you're paywalling it, you're white labeling it, and then you're putting it on a web app. So it's really important to know how to download one of these repositories. So what we do here is we can either download it directly like this, or we could click on this link, we could copy it, then we can open up our terminal. So I've got Ubuntu on Windows, which is sick. Love Ubuntu. Make sure this is a little bit bigger. Let's see how I make this bigger. Hold on. Can I not make it? All right. So what we do if we want to download something is we say, let's see, cd home, make directory hello, cd hello. Okay, so here's what we do to download. We say git init, that initializes this as an empty git repository. Then we say git pull, we paste in the link. Where's my link? Here's my link. Ubuntu. Oh my god. Git init, git pull. There we go. And it's going to pull that repository. Boom. Now, here it is. And now I can cd into it. Boom, there it is. All right, so let me open up Sublime Text and let me take some time before I go into the code to see if there are any questions, concerns, any above. Let me make myself a little bigger for a second. Okay, how are we doing here? Yes, Carl, or we can use git clone. Sumit says the week 1 course, it was overwhelming for a beginner. The concepts not taught deeply enough. Is the rest of the course similar where you teach us for 40 odd minutes, rest we learn on our own? No, the rest of the course is not similar. So, you know, we have a wide range of capabilities in this course. And it's hard to make a singular standard curriculum for people with such varying backgrounds. So what I've done is I've collected the data from week 1 to improve the next weeks. I'm all about that data analysis, the data collection. And what I will do is make sure that we have more resources, whether it's videos or reading links, that accommodate all skill levels. So all that is to say, I have heard you, and I will improve on week 2. Next question. Please suggest a JavaScript tutorial. Sumit, the TensorFlow JS docs are the best in the world. For machine learning for JavaScript, go right to those docs. I have a link for you to that in the week 1 course material. Jacques asks, should we focus our attention on an overarching project that covers one of the modules? For example, a bigger healthcare project than the one in week 1. Jacques, so we have 2 big projects that I'm going to assign to you guys, and that's the midterm and the final. And I'm going to give you guys 2 weeks to complete those. All right, so those are the ones that you should be focused on in terms of an overarching project with a lot of sustained enthusiasm. So for say, you know, your idea here, that's a midterm idea. So I would keep that in mind for the midterm. All right. Okay, lots of questions. I'm only going to answer questions I have not yet answered yet. Kartik asks, do you see a possibility of hosting a machine learning based app for users to download from the Google Play Market? Of course, that's how you get it out to people. You want to put this on the Google Play Store. You want to put this on the Apple App Store. You want to put this on the web at a website. You want to have a mobile web version. You want to reach people everywhere you can, okay? And so tools like Flutter, tools like React Native, which someone mentioned here, but I prefer Flutter. Tools like Node.js or Flask. These are all web and mobile frameworks to get your apps out there into people's attention spans, into their perceptions so they can build something. 2 more questions and we're going to get back to the code. Do we need to download any software before we start? Yes. I think I talked about that in the week 1 course material, but let me repeat. We need to install, first of all, basic Python functionality, which most versions of Windows will have. Most Linux versions, OS X has it. So the ability to run Python from the command line, yes. And then as we go through the course, you'll have to install different dependencies to do the tasks that we need. TensorFlow.js, what's in my eye? TensorFlow.js is one example. And then that's really it. And then Flutter as well, and Android Studio. So Flutter, Android Studio, and Python are the 3. And then the rest are just Python dependencies, which we can download using pip, the Python installer. One more question, and then we're back. Yes, Vineet, don't worry. Flask and TensorFlow, I'm going to be talking about Python in this as well. We're going listen, the rest of the course, we're going to be using pretty much only Flask. I want to start off with just pure JavaScript because it's just it's too easy for me not to. It's just too simple. Like JavaScript is so beautifully simple. A Flask is more powerful. Flask will allow you to scale. And that's why I want to move Flask to the later parts of the course. All right, so back to this. All right, let's get to the code. Let me make myself smaller. Ooh. All right, back to this. So when we download that Iris code, now remember what we saw there. Let's go in to see what is up there. So first of all, look at this repository. They've got a Python folder. What? And then they've got some JavaScript. They've got some HTML. They've got a Yarn file. So let's go through what each of these files are. What are they doing here? So remember, in the web app, they had two options. We could either load a hosted pre-trained model, or we could train the model from scratch. So what they've done is they've done this twice. They've done this training process twice, once in Python and once in JavaScript. So basically they did the same thing in Python and in JavaScript, just to give two examples of two different languages. Now, this is why I picked this example, because we can see how the process works in Python, and then we can see how it works in JavaScript to show that the code is really just a different way of doing things. Really, the logic is the same. So let's go through the Python example first. These are just standard Python functions. Like this is nothing. Keras is a machine learning library that lets us build. It's actually a part of TensorFlow that lets us build neural networks, a type of machine learning model. NumPy lets us perform matrix math operations. In this case, it's going to allow us to perform a data pre-processing, formatting our data to get ready to be fed into the machine learning pipeline. TensorFlow.js is the machine learning library that we're going to use in conjunction with Keras. And Iris data is all of those Iris examples like this. It's a CSV file that contains all of this, these 5 classes right here. Now, this training function is the function. It is the function that we care about the most, because what it does is it's how our model will learn from the data to predict the correct label. Now, all the time in machine learning, you're going to see the same kind of 10 lines of code with Keras right here. Right? You're going to get so used to seeing this over time. I've been looking at this for years, basically. I've been explaining this for years, but to show you guys what I mean here is that first we take our data set, we split it into training and testing sets. So what that means is we say petal length, petal width, sepal length, sepal width it's the X data. It's the input data. That's what data X is. What do we label it? Data X is all these features. Data Y is the label, the target, whatever you want to call it, and that's the class, the target variable. Right, so we split it down the middle just like that. So it's all the input data and then what we want to predict. That's the first step. Then we say if sequential. Now what is sequential? So there are two types of Keras models. There's the sequential model, and then there's the functional model. And pretty much all the time you're going to see sequential. Sequential means we're going to build a model that, actually this image is way better right here. Check this out. Look at that. It's basically a stack of layers. Each layer is a series of matrix operations. So we build a model, we say it's going to be sequential, and then we say add a layer. Don't worry what all of these layers are. Just know that we're just adding layer after layer after layer after layer, and that's basically a sequential model. We're going to be talking about different types of models later, but right now, just know we defined it as sequential. We add a layer, we add another layer, we add another layer, we add another layer, okay? Now, what this guy did is he said, or she said, if the model is sequential, add these 2 layers. If it's not sequential, add these 5 layers. But let's right now just focus on this sequential model, because in this example, it's going to just be a sequential model. Now, what are these magic numbers? What's 10? What's 3? Now, this is going to be in the neural network lesson next week. But let's just say that when we build a model, all it really is a series of matrix operations. Wow, my little rap is a Google search. But basically, very briefly, what's happening here is, oh my God, it's math. You gotta love math. Don't be afraid. Don't be afraid. What we do is we say all of these X's are data points, and they all have weight values. And so what's happened is, I really want to start explaining neural networks and machine learning right now, but that's going to be in week 2. But let's just say that we sum up all of the values from the input data, okay? That's what the sigma notation means. Okay, and we multiply it by the weight values. This is what's going to be learned over time, the matrix operations that are learned over time. And then we add a bias value to make sure that it can learn both linear and nonlinear functions. We apply an activation function to it that does the same thing. It allows it to learn both linear and nonlinear functions. And then we have our output. Now these weight values are what's learned over time. It's what's trained over time. Now I'm actually going to refer you, just for now, just because I can't help it, to my friend's video right here. Hey, there he is. There's Grant's video. But how does it go? It's like, but what is a neural network really? I love that line right here. Look at this. In these 3 videos, and it's like not even my videos, but I love it that much. He does it so well. Look at this beautiful animation here. Oh my God, what is that? Manum magic. I'm learning some of that Manum, by the way. You already seen it, right? Yeah, see, there's so many skill levels here. Oh no, I'm showing you what I'm learning right now. Quantum computing in the brain. Let's see this paper I was reading actually right now. Like if you want to know like where I'm at in terms of machine learning, quantum information in the Posner model of quantum cognition. What else was I reading over here? Can quantum physics help solve the hard problem of consciousness? So this is going to be in week 10, all right? No, I'm just kidding. I'm just kidding. Don't worry about this. This is like week 50, or actually whenever you guys want to. I mean, but anyway, let's not get too off track here. Back to, let me make myself small. I'm small, right? All right, good. So we build a model that way. We say, what is the loss function going to be? There's so many different types of loss functions. We'll talk about that. And how are we going to optimize it? Basically, Adam means gradient descent. Okay, so Adam means gradient descent, which is like the standard way of optimizing a model. We're going to get to this all in week 2. We fit the model. We fit the model on the data. So this is the actual training process right here. This model.fit says, I want you to train this AI model that we've defined right here. We've defined it right here, the series of linear algebraic operations, just, add, addition, subtraction, multiplication, just a series of operations over and over and over again. I want you to train this model, like input this data as a set of numbers into this model, perform all those operations, and then you're going to have an output, and we're going to compare that output to the actual output. And then we're going to say how many epochs, how many iterations do we want to train it for, and we define how many epochs as well. And then we're gonna make those predictions, and we're gonna test how well those predictions perform, and that's gonna show us our accuracy. At the end, we're gonna save our model as a Keras model. Now, this is the great thing about TensorFlow.js is you can save a model as in this convertible file format. And then that's it. So that's the deep part. Now let's look into the data. So in the data part, we have our classes, and then they are building this data from scratch. Now, a lot of times you want to import your data from CSV, but I guess since this is a simple example, they just hard-coded this data into a giant array, which we can see here. And now remember, these are all the values that we saw right here. It's the same thing, right? So, so we have 2 files. We have one file that makes the model. We have another file that both creates the data and loads the data. Now, the loading data part is really interesting because what we're doing is we're splitting it into both an X and Y component. Now, remember, we had that function right here, load data, data.load. What it did was it said, take that data, split it. Now, this is the great part about NumPy and with, what's that other data processing library? Yeah, NumPy. And we split it into 2 different categories. And then it says convert it to 1 hot. So notice right here it says to 1 hot. And then what is 1 hot? Well, 1 hot encoding, glad you asked. 1 hot encoding is a great way to very simply take some data and convert it into a format that would that is unique. So every data point is unique, using a series of 1s and 0s. So take this for example. You have all of these words, and we convert each word into a series of 1s and 0s. So each word gets a 1×9 vector representation. So we have 1, 0, 0, 0, 0. That's a man. And then we have a woman who is 0, 1, 0, 0, 0, 0, and etc. Okay? So that's a way to do that. And there are different functions, different equations to turn that input data into that series of ones and zeros. So it's a simple way of converting a data set into a standard representation that we then feed to our machine learning model. All right, so that's that. Now, I wanted to show you the Python part so I can show you the JavaScript part to show you how it's very much similar. I actually want to show you like every single file here. Let's just look at every single file. So these are the two testing files. Now, no one talks about testing, but testing is basically a way to make sure that when you run a web app, when you run a mobile app, that the predictions you make, the actions that your app takes are not going to fail. They are fail safe. And the assert functions that are a part of Python will input fake dummy data to ensure that it's going to give you the output that you want. So testing is for when you are actually putting your web app or mobile app out there in production for users to use and to make sure that nothing fails. So before I go into the JavaScript, I want to answer some questions again because I think we have just a little bit of confusion in the chat. So let me make myself a little bit bigger. Hello. Okay. So let me answer some questions here. Only answering questions I haven't before. Flying Marvin says, I can understand what you're saying, but I have no clue how to write this stuff. Marvin, I want to answer something for you. Okay. This is the secret. You ready for the secret? Get ready for this. Most developers do not code everything from scratch. It is a series of copy and paste operations from the internet. That is like, how do I, say for example, say I want to build an app that will create a chatbot that performs financial advisory for me. So I can talk to it. It could say, hey Marvin, I can see your balance. And based on your balance, I'm going to suggest that you invest in Apple stock. And I'm going to also suggest that you save $2 a day in general. Now that seems way complicated to make, but by the end of this course, you will be able to make that. I promise you that. Okay? So, because it's actually not that hard. But think about this. I would then, if I'm thinking about how to build this, I would split that functionality up into modules. First, I'll create a chatbot module. That's the highest level. So how do I make a chatbot? Well, the best tool for that is called Dialogflow. Now, how do I make a series of initial Dialogflow statements that the user is going to like? Well, guess what? A lot of other developers have had this problem too. What that means is that code is already going to be available on GitHub. So what I will do is I'll go to GitHub, search for Dialogflow, take that web app, and paste that code into my own code. And then there's got to be some code for processing financial data. This already exists. A lot of financial data in the world. I'll go to GitHub, search for that code, copy, paste it into my app. And what I'm basically doing is it's like Legos. It's like building blocks. It's like bricks in a building. You're taking existing bricks and you're putting them together. You're polishing them. And you're saying, hello, we're all putting a paywall. Here's my app. Pay me for it. This is how it works. This is how the people I know in Silicon Valley do it. You know, it's called white labeling. So if you don't understand how every line of code works, that's okay. You don't need to. Well, as long as you understand the basic bare bones idea of like, okay, this model, I'm loading the data. I'm training the model. I'm making a prediction. I'm serving it in a web app. The HTML looks like this. The CSS looks like this. The JavaScript is doing this. You're good to go. Two more questions and then we're going back to the JavaScript. Don't go anywhere, guys. Sumit, I still do this. I still do this. When I'm doing this quantum information processing to try to figure out the secrets of consciousness and write this paper in 2 days so I can make a video in 6, I'm still looking at code snippets about quantum computing. Okay, great question. Do we need to have, Shashir asks, do we need to have a Flask backend or is everything in TensorFlow.js? Great question. It depends. I hate saying it depends. But let me say this. You will ideally want a Flask backend. Yeah, because you want one language. You don't want to be doing, a little bit of JavaScript, a little bit of Python, a little bit of this, a little bit of that. You want to be just focused on one language. If you choose to use Node.js and TensorFlow.js, it's all JavaScript, right? Front end and back end. If you choose Flask, you can do both front end and back end in Python and some JavaScript. There's always going to be a little JavaScript. You can't escape JavaScript. But if you want to build something seriously scalable, Flask. One more question, and then we're going to resume. What's the other question? The live stream is going to be about 10 minutes longer, I would assume. What are the hardware requirements for my laptop? Really, we're going to be using the cloud to do a lot of training, so any kind of GPU. How to place ourselves in top rankings on Kaggle? Great question. That's a great question. You want to get really good at getting really high predictions for your models, really accurate predictions. And what that means is you've got to know what these magic numbers are, which means I'm going to make myself smaller. All right, here we go, back to the code. So that means you want to know what the ideal numbers are here, because those are the winners of the Kaggle competition, which we'll get to. Now, look at this, data.js right here. So first of all, they said, okay, so all that Python code was just an example, all right? So that was just an example code. Now we're going to do the same thing in JavaScript. Here are our classes, and here's the input data. Got it? Now, convert to tensors is a function that will take the data and convert it to tensors. What's a tensor? What is this? Check this out. Scalar, vector, tensor. Ta-da! A scalar, these are linear algebraic terms. A scalar is a single number. A vector is two numbers. A matrix is, sorry, let me say that again. A scalar is a single number, a one-dimensional or a zero-dimensional number. A vector is a one-dimensional number. A matrix is a two-dimensional number. A tensor is an n-dimensional number, or set of numbers. A set of numbers is ideal. Tensors can, it's not just 3 dimensions. Tensors can be 5 million dimensions. They are n-dimensional. So however much data you have, that is a tensor. It's n dimensions based on the amount of data points that you have. And guess what? A lot of data is n-dimensional. There's a lot of different dimensions where each dimension, this is 1 dimension, this is 2 dimensions, this is 3 dimensions, this is 4-dimensional data right here. And so tensors are basically a way of grouping that data together that we can then feed into a model. Now we're going to randomly shuffle the data, okay, split it into training and testing sets, same things. Creating a 2D tensor to hold the featured data, 1D tensor to hold the labels with one hot encoding, same thing we did before, split it into training and testing. Okay, so this whole function was to just do some data pre-processing. So we created data, pre-processed it, generated it. So this is just if you want to generate some random data, okay? So that's just the data folder. Now in the index file, now that's exactly what we saw right here. This is all of this is coded. This is a lot of, train model with all the buttons and, all that stuff. And then we have the CSS, which is going to be pretty. Build resources, by the way, is basically a bash file that will run the code. So if you want to run the code, you say yarn and then yarn build. And basically, this build resources.sh file is a shell file that's going to run a series of commands on your command prompt that are triggered when you just run 2 commands. So it makes it easier to install and run the app. Now, index.js is really where the good stuff is. This is the good stuff right here. So remember that training loop that we did in Keras right here. Well, guess we do the same thing in TensorFlow.js, right? The same thing. It's sequential model, add the layers, summary, optimize, training loop, predict on manual input. This is the prediction function. Okay, calculate and draw a confusion matrix. Interesting, confusion matrix. That is to, that's going to return the predictions as a single matrix. So it's a collection of matrices, which is going to go all of these right to HTML, right to the client side. And this is evaluation on testing data. So also, a lot of times you'll find pre-trained models on the web, which you can just pull into your web app. So you don't even have to do any of this training. There already exist pre-trained models on the web. This is called the model zoo. There's a lot of model zoos out there. And then this is just a bunch of event listeners. So, whenever you click load model locally, save model, all of these are executed. The loader is going to load all those functions. It's got a bunch of TensorFlow functions for that. Load the data into the DOM, the document object model. Here are all our dependencies right here. The README. This is what runs on command line. And this is what builds the UI. It's a bunch of colors and little CSS, all with JavaScript. And then there's another set of dependencies. We could choose if we want to use Yarn or NPM. All right, let me get some feedback here. Let me get some feedback here. All right. So, let me see what you guys are saying over here. Tyler said, this stuff is complex. This stuff really, man, it really isn't complex. Like, when I started, it was complex for sure. But when you just stare at this long enough, when you start just like see over and over and over and over again, like all these different web apps, you realize like it's just doing the same thing. Build a model, train the model, perform predictions on the web or in a mobile app, add some pretty CSS, add some HTML, and add a paywall with Stripe or with Braintree, and that's how it goes. There are two lines to run the code: Yarn and then Yarn. What was it? It was Yarn and Yarn Watch. Two more questions. Everything is going very fast. Cuphill, I hear you. I hear that feedback. Next live stream, I will improve. Debian, no quantum. All right. I mean, guys, I don't want to take you from week 1 to week 5 million with quantum right now. Like, I'm still trying to figure out the nature of consciousness and how it relates to machine learning. And let's start simple, guys. Let's ask those questions later. Is there a Git repo for what you are looking at? Yeah, it's, let me paste it into the chat again. And you guys should share it around in the Slack channel as well after this as well. But here's the link. David, great point. I will screen the questions and then I will stop myself from losing focus in the next one. Jacqueline, I actually don't have teaching assistants, which is quite ambitious, I know, but I also have a lot of time to do this. I have no other obligations. My students are my relationship. So I'm very much devoted to this course, this class, answering your questions, being there for you. I watch all the feedback in the Slack channel. I'm there, okay? So it's all me. I'm making the lessons, I'm helping people. Yes, I'll send over all the links. As a beginner, Flying Marvin asks, great question, how long should the reading assignment take me? So I realize, guys, that the reading assignment for this week is long. It's not going to be as long for the next weeks, but I specifically made this one long because, you know, there's such a wide range of prerequisites. There's such a wide range of backgrounds in this course that I wanted to make sure that everybody had some kind of basic knowledge here. So I kind of overshot, and I went on the conservative safe end of making sure that All that basic knowledge is there. How long should it take you? I think it should take you 8 hours. 8 hours, max. If you can read faster, probably like 5 hours. So 5 to 8 hours. Will our projects be graded? Yes. Iron Man, do you answer your email? Yes. And it's me. It's not some assistant or something. It's me. I'm answering the emails. See, Zanwei says, I love your walkthrough, but I'm bored by others' questions. We've got a lot of different skill levels in this chat. I mean, you know. And one more question. Great question. Should we read research papers related to ML and try to code them by ourselves? If someone else can do it, it's not necessary to even understand it. If we can simply put to our code, you can absolutely do that. Urban Analytics, could we collect the collections before, rate them via Reddit so you can focus on the most important ones? Yes, that'd be great. I will, yeah. I'm taking this into account. I will have a more moderated screened version of questions the next live stream. Okay, the last question is, how long should the assignment take us? So the assignment, I would say, should take you, it's actually pretty short. I think the reading is going to take you longer than the assignment. I would say 4 hours. 4 hours for the assignment, max. Okay, so that's it for the live stream. Thank you guys for showing up. I will be in the Slack channel after this. And this is exciting. I hope you guys enjoyed the live stream. Love you guys. I will see you in the Slack channel. Week 2 content comes out on Sunday. Every Sunday we're gonna every Sunday I'm gonna be releasing content. So a lot going on in my head. It's super exciting to see you guys, and I will improve the next live stream next week. Same time, same place. See you soon.